We're going to go over the nomenclature of organic compounds. And the first one, for us to be able to name this one, we need to identify the functional groups which are present. We have got an hydroxide, and a double bond, and also a chlorine, which is an halogen. Hydroxide are functional groups of alcohols, and alcohols have got more priority, followed by alkenes, and then halogen at the end. So we need to give the lowest number to the alcohol functional group, followed by the alkene functional group. So in this case, we're going to start naming from this position. There's no carbon here to name, so that will position number 1, number 2 here, number 3, number 4 there. We couldn't have started here as number 1 because the double bond would have received a lower number. I mean a much higher number. So to name now this one, since more priority goes to the hydroxide, that is going to be the parent name. I'll first name the chlorine 4-chloro, okay, and then the whole chain has got 4 carbons, that is a bute. So it's supposed to be butane, so I'll just say bute, and then state the position of the double bond at position number 1, and then put ANE. But this is not the parent name, so I'll remove this E at the end and put a dash, and then state the position of the alcohols or the OHs at position number 1, position number 4, and then I'll put a die because there are 2 of them, and then O. So that is going to be the name for this one. Now, same with the next one. First thing, we identify the functional groups present. We've got an OH, a double bond, and a triple bond, also a methyl there. So to be able to name it, we need to give a lowest number to the alcohol because it has more priority, followed by the double bond and then a triple bond. So the first position will be here, position number 1, number 2, number 3, number 4, number 5, number 6, number 7. So therefore, to name it, we'll first name the group at number 6, that is a methyl, so that will be 6-methyl. How many carbons are present in this compound? We have got 7 carbons, that is going to be called hept. But I'll not conclude the name as heptene, so I'll say hept. State the position of the double bond first. It is at position number 2, and then I'll put ENE, but I'll remove the E at the end because that is not the parent name. Put a dash, and then state the position of the triple bond, that is at position number 4, and then a triple bond, that is an alkene. I'll put YNE, but this is not the parent name. I'll still remove the E from there, and then put another dash, and then state the position of the hydroxide, position number 1, and then position number 2, and then put di-O at the end. So that is going to be the name of this compound. And in the same way, we're going to work out C. Identify the functional groups. We have got this one, we have got also this one, we've got also this one. But wait, these functional groups, whenever they are direct linked, they are not counted as 2 functional groups. It's only one functional group. It's a carboxylic acid. Whenever you combine a carbonyl functional group with an hydroxide functional group, you form a carboxylic functional group. So only have 2 of them here. And in this case, the carboxylic functional group carries more priority than a ketone. This is a ketone functional group. If it was at the end, that would have been an aldehyde. And therefore, to name it, we start from giving the ketone a lowest number, which is number 1 of carbon, number 2, number 3, and number 4. And to name this one, the ketone is going to be a substituent group. So that will be at position number 3, we've got a ketone. So that is going to be 3. Now, when you're naming a ketone as a substituent and the anhydride, it carries oxo. That will be the name. So that will be 3-oxo, and then the rest, that is butanoic acid. I have not stated the position of the butanoic acid because it's always at the end. This will always be at the end. Okay. Now for the other one which we have, let's get to see the functional groups which are present. We have got a chlorine. We have got an ether functional group there. We also have this functional group at this point. And now for this one, we have got the O at the end as a functional group, what do we call that one? So that is, okay. So this functional group, which is at the very end here, we have got a carbon here bonded to this thing, the O of this thing. That is an aldehyde. Whenever we've got a carbon double bonded to oxygen, that is an aldehyde. So we'll not count this as oxygen alone. So those are the functional groups. Now, which one is going to have more priority? The aldehyde has more priority than the ether, and the ether has got more priority than the chlorine. And so when naming, highest priority goes to the aldehyde. So this will position number 1, number 2, number 3, and number 4 there. So now how do we get to name it? So our first name, that means this is a group and also this is a group. The main chain is going to be an aldehyde. At position 4 we have got a group, so we have got 4 chloro. And then at position 3 we also have another group. Now that group is a what? Is an ether. An ether where this portion is a methyl, so this is going to be called methoxy. So this is methoxy. And then now the whole chain has got 4 carbons, that is going to be called butane. So it's supposed to be butane, but because it's an aldehyde, we add Al at the end, so that will be butana. Okay. Why haven't I stated the position of the butana in this case? So if this functional group wasn't at the end, it would have been a ketone. So for an aldehyde, the functional group is always supposed to be at the end. Otherwise, if this wasn't at the end, that was no longer supposed to be called an aldehyde but a ketone. So it's more no use giving it even the position. Now let's get to look at this one. Again, we need to identify the functional groups which are present in this compound. We have got NH2, that is an amine. We have got C double bonded with oxygen. What functional group is that one? Okay, and just pardon me, this is, that was supposed to be just a single bond and an H there. Okay, so we are saying this is an amine, and then we have got an alcohol functional group. So those are the two functional groups which are present. Now, which one receives more priority between the alcohol functional group and the amine functional group? So the alcohol receives more priority, and therefore to name it, we'll start in the direction such that the alcohol is going to receive the lowest number. So that is going to be it, and the alcohol is going to be the parent chain. That means this amine is going to be just a substituent group. So at position 4 we have got an amine, but when you are naming an amine as a group, that becomes amino. So that is going to be 4 amino, and then this compound has got 5 carbon, that is going to be called pentane or pentane. There is no double bond there, that will be pentane, but I'll remove this E at the end because it's really not an alkane but it's an alcohol. And then state the position of the double bond. It's at position, I mean not the double bond but of the hydroxide, position number 2, and then I'll put the O at the end. So this is going to be the name for amino pentan 2O. What of the other one? How do we get to name it? We are going to identify the functional groups which are present also. We have got an aldehyde functional group at that point. We have got an alcohol functional group here. We have got an amine functional group. This will not be counted as a ketone and an alcohol, but together it is a carboxylic functional group, and the carboxylic functional group carries more priority than any other functional group. Therefore, starting to name, we should give the lowest number to the carboxylic. So this will be 1, then this will be 2, this will be 3, this will be 4, this will be 5. So this is a carboxylic acid with 5 carbons. And then the groups, we've got amino. An amine as a group, we name it as amino. An alcohol as a group, we name it as hydroxy. And then an aldehyde as a group, we name it as oxo. So which one comes first in the alphabetical order? Oxo, hydroxy, amino. It's amino followed by hydroxy. So I'm going to say 2 amino dash 3 hydroxy and then dash 5 oxo. After we do that, now we are going to look for the name of the longest chain. Chain has got 5 carbon, that is pentanoic. Okay, pentanoic acid. That is because it is a carboxylic acid. So that is going to be the name: 2 amino 3 hydroxy 5 oxopentanoic acid. Now how do we get to name this one also? Well, to name it, we can see this is an alkane because there's no double bond, there's no other functional group. So look at this one. How many carbons are there? We've got 1, 2, 3, 4. And then for this one, it has got 6 carbons. That means this thing is going to be a substituent. But wait, we have got 2 groups here. So the one with more carbons is going to receive more priority. So this is going to be position number 1. This will be position number 2. This will be position number 3. We shouldn't have gone in this direction because we're going to get a higher number for the methyl there. So that is going to be it. So at position number 1, but what group is this? Well, whenever we see this group, this is a sec-butyl. And if we get to see something like this, and then we are connecting something at this point, this is a tet-butyl. We can also have something which goes something which gets to make something like more like a cross. Okay, there are 4 carbons, but it's making more like a catapult. That is going to be called an isobutyl. So these 3 types of butyls, we need to get to know them. So this is the sec butyl, and so to name this at position number 1, we've got sec butyl. So that will be 1 sec butyl. I'm starting to name sec butyl. Why? Because butyl comes first than methyl. We are not considering the sec at the beginning. So that is 1 sec butyl and then dash 3 methyl, and then now the whole compound, that is a cyclohexane. So that is going to be the name for that one: 1 sec butyl 3 methyl cyclohexane. Now how do we get to name the last one here? The functional groups present, we've got an alcohol, methyl, and methyl. So alcohol receives much lower number, so this will be 1. And then the next one nearest is this one, so we're going to go in that direction. This will be position number 2, 3, 4, and then position number 5 there. So we'll first name the methyls at position number 5 and position number 2. So again, we need to know that an alcohol functional group has got a much more priority, and so this is an alcohol. So at position number 2, we have got a methyl. Position number 5, we have got 2 more methyl, so that will be 2, 5, 5. Since there are 3 methyls, this is going to be tri, and then we say methyl. This compound is a cyclohexane. But we not call it hexane because it's an alcohol, so it becomes hexano. So that is going to be the UPAC name for this one. Thank you so much for watching the video. If that was helpful, please be sure to subscribe. Enjoy your day.